I'm here today to show you guys experiment 5.2 under our Ohm's Law unit. We're going to take you through testing this circuit out over here. One of the things I always like to point out is if you decide to be an automotive technician, you're going to be reading schematics all the time. So you can take a look at this one, pretty easy to follow. We have our 12-volt battery source, we have a fuse, we have a switch, and then we have our load device or our light bulb here, and then we also have our ground. So a quick way to look at a simple electrical schematic. We're going to start off on the 12-volt scale. We're going to take and show you measure resistance, voltage drop, and current. If you remember from 5.1, it's a very similar exercise. The only difference is we're using a light bulb this time instead of our resistor that we used in experiment 5.1. So let's get started. First off, we're going to measure the resistance of the light bulb. So we set our meter to ohms. Our leads are in the correct ports here. So we have 5.4 ohms. We also are going to have we're going to use the same light bulb here for the 5-volt supply, so we can go ahead and write that in. Always draw your little omega sign, or you can write out ohms, just so we know that you know what you're talking about. One of the things I want you to think about is, it shows you in here if you were to read this, but as this bulb gets, as it's turned on, it's going to create heat as that bulb is working. So as it heats up, resistance is going to increase in this circuit. So all we're doing right now is checking the resistance in this light bulb with it powered off. So I just wanted to point that out to you guys. It will change within the circuit as this bulb changes temperature. So we got this set up in the 12-volt battery tap here. As you can see, just like before, we got our series circuit wired in. We're going to power up our circuit. We're going to set our meter to DC voltage, and we're going to check our voltage drop. Voltage drop is just right across the bulb. Notice my meter leads are reversed. You'll see that from time to time with me. So we'll keep it again simple. We have 12 volts. Now we're going to switch our meter over to measuring amps. Take our red lead, put it over in the amp port. We'll just, again, very important, measuring current. You have to break open the circuit. We're going to put our meter leads in series so we can measure the current of this circuit. We have 240 milliamps. That's how much this light bulb is drawing. That's how much current this circuit is using on the 12-volt supply. We're going to switch it over, turn off our circuit. We're going to switch over to the 5-volt tap. Now, some of you are probably already thinking, what's going to happen to this light bulb? Is it going to be brighter? Is it going to be dim? Well, we're reducing our voltage, so you're about to see. As you can see, voila, the light bulb is a little bit dimmer. We have less voltage, so in turn, we're going to have less current flowing through this circuit, which making the light bulb a little bit dimmer than on the 12-volt scale. So our voltage drop here, check this out. We'll just say 5 volts. Now we'll check our amperage. Gonna set the meter again to amps. Again, we got to move our red lead over to the amp port. We're going to take and put this in series, power up our circuit, and we have 144 milliamps. One of the things it's asking here is, why is the bulb not as intense when the 5-volt supply is applied to the circuit? We kind of answered that already. We have less potential energy here, less potential, meaning we're going to have less available for this circuit, and that's why the light bulb is going to be a little bit, I say dimmer, but a little bit less intense than on the 12-volt scale.